Take care of the minutes and the hours will take care of themselves. Good morning, Galaxy of Intellectuals, Chief Guest, Guest of Honor, Chairman JGEI, Resource Person, Managing Director, Chief Coordinator, Dean YCT, HOD of Electrical Department, faculty members and participants. On the first day of Faculty Development Program on Clean and Green Energy for Sustainable Development, we welcome you all in the gathering. It is a matter of great happiness to welcome you all in the Faculty Development Program organized by the Department of Electrical Engineering, YCT. Success is no accident. A dream doesn't become reality through magic. It takes sweat, determination, and hard work. There is no secret to success. It is the result of perfection, learning from failures, loyalty, and persistence. Now it's time to introduce Yogananda College of Engineering and Technology to each one of you present here. YCT is an institution which has been famed to always take the road less traveled. While giving pure academics, YCT has always endeavored to provide its faculty with that little extra something which makes this college distinctive and unique. We understand the need for continuous improvement and innovation in knowledge disbursement. As our faculty conquer peak after challenging peak of success, we deem it our duty to provide them with all the support in the form of state-of-the-art infrastructure, providing them with challenging opportunities to test their mettle and the required guidance, motivation, and human values, which are the real essence of life. Engineering colleges were established to train graduates when well in the branch, have a holistic outlook, and have a desire to work for national needs and beyond. Electrical engineering was established in the year 2013. Department runs so many activities so that faculty gets involved in addition to their academic curriculum. During the tough time of COVID-19, when we were switching from offline to online, the department organized faculty development program in the year 2020 on the topic Energy Management and Sustainable Energy. Keeping it as a reference this year, Department of Electrical Engineering organized a 5 days faculty development program on clean and green energy for sustainable development. Sustainable development is a pathway to the future we want for all. It offers a framework to generate economic growth, achieve social justice, exercise environmental stewardship, and strengthen governance. Keeping this in mind, the department has organized a faculty development program on clean and sustainable development. Now, I would like to invite HOD Electrical Department YCT Engineer Lavnish Talwar for the welcome address and introduction about this faculty development program to everyone present here.
Thank you, Wesley. It is audible?
Yes, sir, it is also audible.
Thank you so much. Respected Chief Guest, Guest of Honor for the day, Honorable Chairman, Jambal Group of Educational Institution, Resource Persons, Chief Coordinator YCT, Dean Academics, Head of the Departments, the faculty members of Electrical Engineering Department, and the participants. A very good morning to all. I, Lavnish Talwar, Head Electrical Engineering Department at Yogananda College of Engineering and Technology, would heartily welcome you all for the 5 days faculty development program on clean and green energy for sustainable development organized by the Department of Electrical Engineering. I extend heartfelt gratitude to welcome our esteemed chief guest, Professor Dr. Rajni Khan, Director, College Development Council, University of Jammu. I also welcome Professor Dr. Pavni Shebrol, Head Computer Science Department, University of Jammu. I welcome Honorable Chairman, Jambal Group of Educational Institutions, Engineer Vidhi Singh Jambal, eminent speakers for the 5 days FDP program of the various institutions, Chief Coordinator YCT Engineer B.R. Verma sir, Dean Academics YCT Engineer Dinesh Gupta sir, the faculty members of Electrical Engineering Department, and most important, all the participants from the various parts of the country. Faculty vitality is the main ingredient to enhance the professional education and competence. Enriching the faculty vitality in the key domain of teaching, assessing, research, professionalism, and administration is pre-received to improve educational environment significantly and enhance the academic performance of the learner. Faculty development program has been considered as a standalone educational pedagogy in fostering the knowledge and professional skills of the faculty. Keeping these facts into consideration, the Department of Electrical Engineering organized 5 days FDP on clean and green energy for sustainable development. Now it's the time to introduce our esteemed chief guest, for the day, Professor Dr. Rajnikant, Director, College Development Council. They need actually no introduction. Professor Rajnikant sir, one of the senior most professor in the university, brings along with him a teaching cum research experience of almost 30 years. Prior to being appointed as CDC, Professor Rajnikant sir was holding the position of Chief Coordinator Offsite Campuses of Jammu University. He also remained the Director of Kathua and Ramnagar campuses of Jammu University. Besides this, Professor Rajnikant sir also remained head of the Department of Physics and Electronics and also the Director, UGC Human Resource Development Center, Jammu University. With a doctorate in physics and postdoctoral experience in Boyce Cost Fellow from coveted Oxford University, UK, Professor Rajnikant sir has published over 400 research papers in various international journals. He has so far guided 25 PhD scholars and more than 50 scholars in the research field of X-ray crystallography. Professor Rajnikant sir also holds the distinction of being conferred with the first J&K government DST Young Scientist Award in Physics in 1991, widely recognized for his pioneering work in X-ray crystallography. Professor Rajnikant sir has so far evaluated 19 national projects in the area of expertise. Sir also has the honor of delivering invited lectures in USA, Bangkok, Thailand, and the University of Osaka. Recently, he was the first person from Jammu and Kashmir to get the prestigious fellowship award, elected as Fellow of Royal Society for Chemistry, London, UK. Moving towards the second, we have the guest of honor, Professor Dr. Pavnish Abrol sir. Sir, I welcome on this FDP program. Dr. Pavnish Abrol sir is a professor and head of the Department of Computer Science and IT, University of Jammu. Dr. Abrol has more than 20 years of teaching and research experience at postgraduate level. Besides PhD in computer science, he also holds the degree of MBA HRM. He served as Royal University Bhutan for the 2 years under Colombo Plan of Government of India. He has received INSA Visiting Fellowship in 2007 to visit IIT Kanpur for research. Dr. Abrol has more than 50 research publications in various reputed national and international proceedings and journals. His research interest includes arrow-based texture analysis, image forging, and authentication and eye gaze technologies. He has produced 3 PhD scholars and currently 5 scholars are working with him. Presently, Dr. Abrol is Editor-in-Chief of peer-reviewed referred International Journal of Scientific and Technical Advancement, IJSTA. He has been a member of various committees and academic bodies. Dr. Abrol also served as head of the Department for Remote Sensing and GIS and Director, Riyasi Campus, University of Jammu at Riyasi. Dr. Abrol is a fellow of Institution of Engineers, IE, Kolkata, and Institution of Electronics and Telecommunication Engineers, IETE, New Delhi. Presently, he is the chairman of IETE, Jammu Sub-Center 2020 to 2022 and vice president of Vigyan Parishad, J&K. Now it's the time to introduce our worthy chairman, sir, the man of distinct vision and a fountainhead of illuminating ideas, an idol of knowledge and experience and inspiration to all of us, our honorable chairman, Jambal Group of Educational Institutions, Engineer Vidhi Singh Jambal, sir, who manages various colleges not only in Jammu but also outside the Jammu with a very rich experience of almost 27 years. Presently, with the cooperation of society, the group has grown over the year and it is present making following institutions: Institute of Management Sciences, National College of Education, Yogananda College of Engineering and Technology, Institution of Engineering and Computer Sciences, Tavi Engineering College, and Tavi Polytechnic College. I wholeheartedly welcome our chief guest of the day, the guest of honor of the day, and Honorable Chairman, Sir JGI. During this 5 days FDP program, we have organized talks on green and clean energy, in which we have various eminent speakers from the various universities and engineering college. The first day of the event was by Dr. Sanjeev Anand, Assistant Professor, School of Energy Management, Shri Mata Vaishno Devi University, Katra. He will deliver the talk on thermal selective coatings and its enhancement characteristics for efficient power generation through parabolic collector PTC. Second day FDP program will be shared by Engineer Shafkat Nabi Mudgal, Head of the Department of Electrical Engineering, Baba Ghulam Shah Badshah University, and the topic for the talk is deregulation of the power sector for sustainable development. During the third day, we have Dr. Ycet ANAND, Assistant Professor, School of Mechanical Engineering, Shri Mata Vaishno Devi University, Katra, and he will deliver the talk on energy efficiency in buildings, a move towards sustainability. On the fourth day, we have an eminent speaker, Dr. M. Marceline Beno, Professor and Vice Principal, St. Xavier Catholic College of Engineering, Tamil Nadu, and he will deliver a talk on AI and IoT for green and sustainable energy. And on the last day, we have eminent speaker, Dr. A. Nazar Ali, Associate Professor, Rajalakshmi College of Engineering, Rajalakshmi College of Engineering and Technology, Tamil Nadu. He will deliver a talk on opportunities and challenges in the solar-powered electrical vehicle. On the behalf of entire team of Yogananda College of Engineering and Technology, I all welcome all the eminent speakers for this today's program. In the last but not the least, I extend my best wishes to all the faculty members, all the participants for this 5 days FDP program. Thank you all. Over to Esli.
Thank you very much, sir, for your kind words. Now, I would like to invite Engineer Dinesh Gupta, Dean Academics, YCT, to say a few words about this faculty development program.
Thank you, Ajli. Am I audible?
Yes, sir.
Good morning to all, the galaxy of intellectuals, guests, faculty, and my dear participants. A pleasant morning to you all. I, Dinesh Gupta, Dean Academics of Yogananda College of Engineering and Technology, Jammu, feel honored and privileged to welcome you all on the inaugural function of 5-day faculty development program organized by Department of Electrical Engineering of Yogananda College of Engineering and Technology, Jammu. First of all, I would like to congratulate Engineer Lavnish Talwar, HOD of the department, and also like to congratulate the faculty members of the department. I feel great proud to say that last year also all the departments conducted faculty development programs successfully. The participants were not only from J&K and India, but were also from abroad. Last year, our college was also selected as only nodal center in the Union Territory of Jammu and Kashmir to conduct a triathlon by Ministry of Higher Education and MIC Government of India. The Department of Electrical Engineering of Yogananda College of Engineering and Technology is organizing faculty development program in association with IIC, that is Institutions Innovation Council, MHRD Government of India initiative. In IIC ranking, I would like to tell all of you that last year our college was ranked 3rd among all the colleges and universities of Union Territory of Jammu and Kashmir, and this year our college is ranked 2nd. It is such a great and privilege to have galaxy of intellectuals present today on the inaugural function of 5-day faculty development program. Professor Dr. Rajnikant, Director Colleges Development Council, University of Jammu, Professor Dr. Pavni Shavrol, HOD CSE Department, University of Jammu, Engineer Vidhi Singh Jambal, Chairman cum Managing Trustee of Jambal Group of Education Institutions, Engineer Renu Bangru, Managing Director of Jambal Group of Education Institutions, and Engineer V.R. Verma, Chief Coordinator of Yogananda College of Engineering and Technology, Jammu. Jambal Group of Education Institutions is established in the year 1993, and today group has 3 campuses, 2 at Jammu and 1 at Shahpur Kandi, Pathan, Punjab. In Jammu, we have 2 campuses, one at Purkhu Camp, Dowana, Jammu, and other at Guda Brahmana, Patoli, Jammu. At Purkhu campus, we have 3 institutes, namely IECS Polytechnic. It offers 3-year diploma course in civil, electrical, mechanical, electronics, and computer engineering. Second college is National College of Education. It offers 2-year B.Ed courses, and third one is Cambridge International School. At Patoli campus, we have 2 colleges. One is IMS, that is Institute of Management Sciences, for BBA, BCA, MBA, and MCA courses. And second one is Yogananda College of Engineering and Technology. It offers 4-year engineering courses. At Punjab campus, we have 4 institutes. First one is Tavi Polytechnic, second one is Tavi Engineering College, third one is Tavi College, and fourth one is Cambridge International School. In this 5-day faculty development program, we have speakers not only from J&K, but also from other part of India, Dr. Sanjeev Anand and Dr. Yatheshtht Anand from Shri Mata Vaishno Devi University, Katra, Jammu and Kashmir, Engineer Shafkat Nabi Mughal from Baba Ghulam Shah Badshah University, Rajouri, Jammu and Kashmir, Dr. M. Marceline Veno from St. Xavier Catholic College of Engineering and Technology, Tamil Nadu, Dr. A. Nazir Ali from Raja Lakshmi College of Engineering and Technology, Tamil Nadu. My best wishes to the organizing team and hope the participants will be benefited from this faculty development program. Thanks, and over to Azli. Azli.
Thank you very much, sir, for your kind words. Now, I would like to call upon the person who has consumed himself to change the society and light the darkness in the life of students, the man of distinct vision and a foundation head of illuminating ideas, an idol of knowledge, experience, and inspiration to all of us, Engineer Vidhi S. Jomwal, Chairman, JGEI, to say some knowledgeable words to all of us.
Sorry, sir, your mic is off, sir.
Good morning.
Yes.
Good morning to all. At the outset, I extend my best wishes to the Department of Electrical Engineering, Yogananda College of Engineering and Technology, who have taken lead in conducting this faculty development program of 5 days duration. First of all, I convey my thanks to Professor Rajnikant, Director, College Development, University of Jammu, who is a great academician, excellent researcher, able administrator. Let me share with you, Professor Rajnikant has always been there whenever there is a concern for developing faculty or future of the students. For years, I have been saying that whenever we were in distress in our institutions or we were deprived of something, Professor Rajnikant came to our rescue and saw to it that we got our due. Thank you, sir. We remain indebted to you. Thank you very much, sir. My sincere thanks to Professor Pavnish Abrol, a great educationist and an excellent human being. Thank you, sir, for being with us today. I convey my thanks to all the dignitaries and their source persons for 2 days for this 5 days program. Let me share with you, Yogananda College of Engineering and Technology has been conducting such programs in routine and has taken lead in very such events. For this, credit goes to all these heads of the departments and of course, Dean and Chief Coordinator. No, I extend my best wishes to the organizers and pray to Almighty that it becomes a great success. Thank you very much. God bless you all.
Thank you so much, sir, for your inspiring words and for providing a platform to develop a complete persona that is a preferable choice in the competitive professional environment. Life is all about chances and opportunities. Never leave anything to chance and never let an opportunity get away. Now, I would like to invite the guest of honor, Professor Dr. Pavnish Abrol, Head Computer Science Department, University of Jammu, to say a few words about this 5-day faculty development program on clean and green energy for sustainable development.
Pavni sir, kindly switch on your mic, sir.
Okay, am I audible?
Yes, sir, you are very much audible, sir.
Okay, ji, thank you, Anjum, and Professor Rajnikant, Director, College Development Council and Dean Sciences, University of Jammu. Engineer Vidhi Singh Jamwalji, Chairman, Jamwal Group of Education. Engineer Renu Bangru Madam, Engineer Dinesh Gupta, Dean, Academics, Yogananda College. Engineer Lavnish Talwar, Head, Electrical Engineering Department. Dr. Sanjeev Anand, Assistant Professor from SMVDU. Members of the organizing committee, faculty of the Department of Electrical Engineering and other departments, participating teachers for this FDP. Very good afternoon to all present. It's a matter of great pleasure that the Department of Electrical Engineering, YCT, is organizing 5-day FDP on clean and green energy for sustainable development. The theme is very appropriate and latest, and I was going through the brochure, and there are some very good lectures which are planned by the eminent experts and academicians around. And this theme goes with the strategic vision and ambitions of the vision of India that the present government under the leadership of Prime Minister Shri Narendra Modi ji is having the thrust on achievement of zero carbon energies. Green hydrogen policy, which has been launched as the National Hydrogen Mission, announced by Honorable Prime Minister on 75th Independence Day, which was 15th August 2021, aimed at meeting the climate targets and making India a green hydrogen hub. So India has now the fourth global position in terms of the installed renewable energy capacity. And there are strong efforts to achieve the set targets for the solar capacity. And there is certainly India's largest renewable energy expansion program. So India's strategy, which has been committed recently at COP26 conference at Glasgow, UK, it included the installation of non-fossil fuel technology, 50% energy requirement from renewable resources, moving to renewable resources, and drastic reduction of the carbon dioxide from the significant reduction from the industry sector and from other areas. So that's the new India, which is emerging as a global, strategic, and visionary country. But then there are certainly challenges. We are in the developing country. We are the developing country with high growth in industrial sector. So the challenge is change in the manufacturing processes, use of alternative for energies, such as green hydrogen in place of carbon significantly, and specifically in the heavy industry sector. And then there are also challenges like strong network of solar energy storage and distribution, new cost-effective technologies and their developments, solar energy generation plants, grid updations. But then there certainly is a strong resolve of the country to embrace the new technologies for the positive changes, to improve the life of people, to take the country ahead and become a global hub for higher learning, technology, innovation, and lead into the 21st century. So to fulfill these aims and achieve such targets, it's very essential to understand the challenges of the society and industry by the students, experts, scientists, engineers. And there is a need to strengthen industry, academia, and academic linkages. So collaboration between research and development, manufacturing industry with engineering institutes is the most important component to achieve such targets. So there is a vast potential of opportunities coming in the area of electrical, mechanical, computer, and civil, and other engineering streams. And hence FDP, faculty development program that are being organized with such theme in such an upcoming emerging area for the students of the engineering branches is a very good idea. And the topic clean and green energy for sustainable development is a well thought and a very good platform that shall provide the opportunity for the students, for the faculties to interact with the leading, discuss with the academicians, and then carry it forward to the students. So therefore, I know that the college has been organizing such events. There was a conference which I also attended. I got the opportunity to attend. So I am sure that this FDP shall certainly be very helpful and certainly provide a great opportunity to the faculties. So I congratulate Chairman Shri Vidhi Singh ji and Engineer Dinesh Gupta ji and the head of the departments and the member of the organizing committee for initiating such a wonderful FTP. Hope that this will provide excellent opportunity for teachers to participating teachers to interact, discuss, learn, and get abreast with the new technology in the field of clean and green energy. Thank you and my best wishes. Thank you very much.
Thank you very much, sir, for your kind words. I would now like to invite the chief guest, Professor Dr. Rajnikant, Director, College Development Council, University of Jammu, to share his views about this faculty development program.
Namaskar. My colleague in the university, Professor Pavnesh Abrol, Dr. Sanjeev Anand from Mata Vaishno Devi University, Shri Vidhi Singh ji, Dean Academic Affairs, Principal, Coordinator of Jamwal Group of Colleges, invited speakers, participants, ladies and gentlemen. I have been listening to the presentations by Professor Pavnesh Abrol and Vidhi Singh ji and Mr. Dinesh Gupta. I got to know of a very important, observation that this faculty development program has been organized to make the faculty aware about the clean and green energy for sustainable development. As we all know, in fact, if you listen to the international groups who are involved in the creation of clean and green energy, and the topic related to carbon and carbon credits and carbon footprints and so on and so forth, these are all very tall terms, and on the ground it appears that very less has been done so far. Actually, so far as providing the clean and green energy to the consumers is concerned. If I have to look at the so-called electric power position in our state, I mean the Union Territory of Jammu and Kashmir, I don't think there is any kind of even academic audit that has ever been made. The way the power is being misused by the civil society, and no regulatory mechanisms are in place. So it appears that India will have to walk miles and miles to reach at this situation of creating clean and green energy. But one thing is very beautiful about it is that the message now has started going across the country and the globe, of course, that people have started organizing some small little meetings of this kind, where academic exchanges are taking place to make the point reach the younger participants, the students who are the future leaders of this country, to how this job can be taken up, and not only taken up but implemented in letter and spirit, so that we all enjoy the benefits of clean and green energy. I'm sure that with the kind of experts you have drawn from Mata Vaishno Devi University, I know personally Dr. Sanjeev Anand is a very knowledgeable person about his research specialization. And the others from Baba Barsha Gulam Shah University, then from some people from Tamil Nadu. I suppose you have some resource persons have been drawn from there also. So my perception is that this 5 days event is going to be quite scintillating and exciting, And I'm sure that all the experts will have good, one-on-one interaction with the participants, and the participants will be able to have first-hand information about the concept of clean energy and green energy, and how this energy can be made sustainable so that our future generations are benefited. I thank you very much, Engineer Vidhi Singh ji, for having given me this opportunity to the participants and organizers of this conference. You may be aware that University National Science Festival, and 75 institutions across the country have been identified, and Jammu University happens to be one of those institutes, and I have been given the responsibility of organizing this event. So therefore, since around 2,000 students are going to be there in the campus in the next 7 days, so the responsibility is quite huge. I won't be able to be in this program for rest of the day. So therefore, I tender my apologies. But before I leave, I would say best of luck to the participants and the organizers for the success of this program. Thank you so much. Namaskar.
Thank you so much, sir, for your kind words. Now, I would like to invite the resource person for the first day of Faculty Development Program, Dr. YATHESHTH Anand, Assistant Professor, School of Mechanical Engineering, Sri Mata Vaishno Devi University, Katra, Jammu and Kashmir, to conduct the session on energy efficiency in buildings, a move towards sustainability. Now, firstly, I invite HOD Electrical Engineering to welcome the resource person, Dr. YATHESHTH Anand, for the day.
Yeah, thank you. As it is audible.
Yes, sir.
So actually, today's session will be taken by Dr. Sanjeev Anand sir. But today in the morning, I will call. I gave a call from Dr. Anand. He has some certain medical emergency, so that is why we have changed the plan. On the first day, the talk will be delivered by Dr. Sanjeev Anand, Assistant Professor, School of Energy Management, Sri Mata Vaishno Devi University. He will deliver a talk on the third day, and now today the talk will be delivered by our another resource person, Dr. Ycet Anand, Assistant Professor, School of Mechanical Engineering. So, sir, I welcome you on this first day of FDP program. So, before handing over the stage to the Dr. Ycet Anand, first of all, I will give you the brief introduction about Dr. Anand. Dr. Anand has done his ME in CAD and CAM and robotics. And after pursuing his BE in mechanical engineering before joining Sri Mata Vaishno Devi University, Katra, he is a PhD in area of exergy and moisture dynamics in building. He is actively involved in teaching and research and has published more than 20 research papers, articles in reputed national and international journals. He has also 30 numbers of various articles in national and international proceedings. He has authored and co-authored a book and 2 book chapters. Ycet Anand sir is also affiliated with many professional societies like ISTE, IEI, SCSI, and ASHRI. His research interests are NZEB, exergy analysis, CFD, and automation. In addition to that, Dr. Anand has also associated with the various organizations. He is a life member of Indian Society of Technical Engineers. He is a member of Institution of Engineers India. He is a member of American Society of Heating, Refrigeration and Air Conditioner, ASHRI. He is also a member of Solar Energy Society of India. One thing that I will tell you, all the participants to be present there. Within a no time, when I get invited for the talk, Dr. Anand, Ycet Anand sir accept my invitation within a no time. And for this, I am very, very grateful to Dr. Ycet Anand. He will invite my invitation and become as a resource person for the day. I hope all the participants get an idea that how he can elaborate the topic that he had delivered on this energy efficiency in building, a move towards sustainability. So this is all from my side. Thank you so much, sir. Ycet sir. Now I hand over the screen to you, sir. Kindly start your proceedings, sir. Thank you so much, sir.
Thank you, Lumens. I hope I'm audible.
Yeah, sir, absolutely audible.
Okay, thanks a lot for your kind words, but it's your humbleness out of which you speak so much. And I would like to thank my organizer, that is Yogananda Institute of Engineering and Technology, for giving me this opportunity to deliver or be a resource person for this event, that is Faculty Development Program. And also to the my extended thanks are also for the administration of the Yogananda and the keynote speakers of this FDP. I've shared it. Hello.
Yes, sir. Yes, sir.
Okay, thank you. So I welcome all the participants to this FDP, and due to some urgency, Dr. Sanjeev Anand could not be the inaugural lecturer for this FDP. So now it is my pleasure to be the inaugural lecturer. So I had chosen this topic, like energy efficiency in buildings, a move towards sustainability, to be a topic of discussion for the FDP, which is titled Clean and Green Energy for Sustainable Development. In my opinion, this is the right platform to discuss such a thing, because in a way the word should go to the masses that how to deal with such an important thing as buildings in which we stay, which are our homes, our places of rest and recreation, and they are consuming more energy than they are supposed to do. So it becomes in my opinion, it becomes an apt topic to be discussed, and that's why I've chosen it like that, since the topic is clean and green energy, and I would like to relate this with how buildings are consuming energy, and also how we can make these buildings a sustainable recreational and retiring space for us, and not uh, at the cost of not uh, uh, generating a discomfortable occupancy for us. So beginning with this, my presentation would be outlined as this, that is, I would first we will discuss the energy scenario, then the impact of building on environment, need of the hour, what is sustainability, then how a sustainable architecture can be incorporated into a built space, and right ventilation and with the right lighting, uh, we can accommodate a sustainable building itself. And this too, with an example or a case study, I would explain to you that how things can be easily mended in the right way. And after that, we would be like, I would be open for discussions with the participants. So the present energy scenario, this is from the stats that I've received from, I've taken from BP Statistical Review of the World. And you can easily see it's a fairly progressive trend in the energy consumption throughout the years, that is beginning from 1965 till 2020, and it is still progressing further. And that means that we are going to consume energy at a very, very higher pace than it is presumed. And of course, in 2020, this pandemic era was not incorporated, and during this pandemic era, we have spent a lot of time indoors, and that too having more recreations to our disposal. That means we were watching enormous TV, we were using all the online platforms to entertain us, and to educate us, and to when we academicians were also having online classes and all those things. Students were having online classes. So in nutshell, the energy requirement of a household was increasing has increased tremendously. And this data is like just exempting that thing out of it. And in progressive years, it is supposed that it is going to increase globally. And when we are talking about a building, then we should understand that how much, if we have to understand it, how much energy is being consumed by a building in as a whole, then this pie chart gives you a fair distribution of the energy that we produce. That energy is consumed in this separate percentages in these widely in these broad sectors of the society, that is building, which is associated with 37% of consumption of the electricity, industrial, the second largest, that is 32%, transportation 22%, and agricultural, that is 2%. So this accounts for a major contributing factor of energy where it is being utilized to an extent, to a bigger extent, for various household or various activities that are a part of a built structure, along with which also associates or accommodates the comfortable dwelling condition that is being generated there. So if we talk about the average annual change in the building energy consumption that is projected till 2040, when we talk about OECD member countries and non-OECD member countries, so these are those countries which are predominantly pretty much developed, so their change of annual energy is not going to be a lot. But when we talk about non-OECD member countries, we can see that India is topping the list with 2.7% increase in the annual and not increase but change, prospected change in the pattern of energy usage. So that means like these are all those countries which are like nowadays which we term to as that they are going to be increasing their development, and with that increase in development, the expenditure power of the person or the citizens are also going to grow, and because of that since the spending power is going to grow, they are going to get more products to their disposal, and they are going to use more electricity. That is as it is projected. Okay, so with this, we can see that what is the building energy scenario of the country. So if we talk about that, the electrical usage in commercial buildings is basically divided into major factors, that is lighting and air conditioning. When we talk about commercial, it are all those these are like your shopping malls, your various shops, your cinemas, theaters, your hospitals, and those other things, including schools and colleges, etc. So predominantly we are talking about lighting and air conditioning, or air conditioning will also include the fans and all those things that are involved to create a mix of air to get a convenient and comfortable dwelling inside it, along with other old stuff like pumping and all those things. That is the major distribution of electricity in a commercial household in India, commercial building in India. But when we talk about residential buildings, our houses, their distribution is like this, that is lighting is 28%, the fans and air conditioning, if they are there, accommodate for 34 plus 7%. Then cooling, evaporative cooling, refrigerator, television, and others are a smaller amount of electricity consuming sectors. So we can understand that out of whatever dominating role we have, whatever proportion of energy utilization we have in a house, in a built structure, whether commercial or residential, lighting and air conditioning, or lighting and establishing a comfortable dwelling condition inside a built envelope are the predominant consumers of energy, like 59% and 31% here in commercial buildings, and 28% and 34 plus 7, that is 41% for air circulation inside the built space to create a comfortable dwelling condition are the two main dominating factors here. So we'll be discussing more on this. The focus of my discussion is going to be on these two factors, that is lighting and ventilation. So coming to the scenario, like what we are using here, this graph shows you that this is from the Indian Energy Outlook 2021, that we are using various devices at our residential places, out of which lighting, fan, TV, refrigerator, washing machine, water heater, air conditioning, etc. are the devices which we commonly use, and how they are distributed in urban and rural areas are shown by the green and the blue bars. Like lighting is through and through, like 100% people are using lighting, and less than 100% people, slightly less than 100% people are using fans in urban area, and in rural area, this many people, this percentage is using fans like that. It is a graph that shows that what appliances are available in the various stratas of the society. And these yellow dots show that what is the percentage share of energy efficient appliances in these areas. Like if I'm using a light, simple bulb, then what is the percentage of people in urban and rural that are using, or what is the percentage of people that are using energy efficient lightings, if we talk about it. So this is it's around 66% of people are using energy efficient lighting, being in total of rural and urban societies. And likewise, yeah, we all know that we are not using energy efficient fans. We just go for the easily available fans in the stores. Then same about TVs, refrigerators, washing machines. We don't bother. Water heaters, we never bother. And the air conditioners, obviously they are awfully expensive, so we are not going to take into the consideration never to get air conditioner which is inverter based or something like that, because it is going to cost you another 30 to 40,000 more than the respective tonnage of the and not energy efficient or not like that. So we are not going to get that. So this is the distribution, and it simply says that how things are scattered, what we are using, and it falls into what category. Now coming to the impact of building environment, how buildings are impacting our environment. That is 40% of the global energy it is consumed by the building, as I've already shown you. 35% of the world's CO2 emission is due to this thing only, that enormous amount of energy is being utilized by the building for various activities, and that is contributing, that is making that that is ensuring that building is contributing 35% to the net CO2 emissions of the in the world. Then 50% of ozone depletions is due to CFCs, and it's like a big figure, and we are mostly ignorant about this fact. 30% of the residents are having sick building syndrome. Now, when we talk about sick building syndrome, there are plenty of people, and in my research with my student, we have come to know that mostly people are not aware about this thing, that the building in which they are living for a longer duration of time is suffering, or in turn is giving them a sick building syndrome. Mostly people don't know, whether being an official establishment or a residential establishment. Then we are contributing, or buildings are contributing to 40% of the municipal solid waste. 25% of the wood is harvested only for the building utilization. 30% of the consumption of raw material is only for the buildings, and 16% of the world's fresh water is gone just to create a building. So this is some data which can be an eye opener for us, that a simple building, a home, how it is impacting the environment. Now, this is the need of the hour because of all the factors that I have already told you. And the need of the hour is that we should understand how the building should be, just setting aside our personal interests, we should just make a building that is appropriate for the time. We should not create structures which are burden for the society and the environment and our Mother Earth in all. So it's our responsibility as engineers also to consider this fact. So that is why, in my opinion, this is the need of the hour, and we should understand and percolate this message as far as possible to the root level, to the farthest root level, so that from there we come up, we can have a better growth and better infrastructure to be developed, which is more sustainable for the future. So now the question arises that what is sustainability? We have been using this word for a longer duration of time, and sustainability is like, it's not only that we have to sacrifice our needs, but we have to mend our needs in such a way that we are meeting that we are accommodating ourselves, and we are also caring of our future, so that they can accommodate themselves in that environment. So sustainability means meeting the needs of the present without compromising the ability of the future generation to meet their own needs. So this is a win-win situation for us and the future to come, or our kids who are like just born, or like 4, 5, 6, 7 or 10 years old at the max, because when they are going to be a part of the society and they're going to be contributing to the society, the environment and the society would be in a very bad shape. If we go on doing or carrying out our activities at the same pace, the things are going to be in a very bad shape. Like recently we had a news that a very dominating country in the world, a big country in the world was having or facing water scarcity. So these things are the future that are going to come. So we have to be very vigilant about how we are consuming things and utilizing our resources. So sustainability means that we have to be we not compromising our present, but we have to think about the future and let them also to be live in peace with the environment. So sustainability in terms of when we are talking about building, as my presentation is going to circle around that thing. So it would be the integration of environmental concerns in green construction. It is water conservation. It means waste reduction. It means energy efficiency. It means healthy structure. When we are talking about sick building syndrome, so we don't want much of that. So that is that accounts for healthy structures and the building's longevity also, because we don't want to create such structures which are going to be lasting for only 5-10 years, that are not going to be economically viable also. So sustainability has a component of economic viability also to it. So we have to think in total. The compromise should not be like that it's not economically viable and still we are going to force it, and the person or the society is not ready to bear that cost of reconstructing it after 10 years or 20 years. When we create a building, we create for generation, and then generation is like it's minimum 50 to 60 years, so like that. So sustainability from building point of view should encompass all these things, out of which we are going to focus on energy efficiency and healthy structures and building longevity, out of which my dominating part would be on energy efficiency, which is going to be focused on two aspects, that is ventilation and lighting for this presentation. So sustainable architecture is like what has happened actually, that due to the development or due to massive developments, the rural population has migrated to the urban sector, and we have created urban heat islands. When we talk about urban heat islands, that means the net energy demand of an urban society has increased because major of the population from the rural India has traveled to the urban area because of the more economic growths and the economic and professional attractions of the urban society. So the crowd of the world has increased towards the urban sector. Then due to that, what has happened, that there has been expansion of the urban areas at the cost of depletion of the natural resources. And when we are establishing or when we are creating natural area, creating urban or increasing the urban islands, in that case, we are and we are demanding more energy simultaneously, because we need to have comfortable dwelling there. We need to establish comfortable conditions there for the occupants to live there peacefully and do their jobs in a convenient and convenient manner. So in turn, what is happening? It is impacting the biodiversity, because we are replacing natural resources. We are abandoning those lands of the natural harvest that is there already. And suddenly the biodiversity is depleted and the entire ecosystem is in shambles. So we need to understand that we have to live amicably with the nature and not spoiling everything. So now there has to be a delicate balance that needs to be managed between the urbanization of the society and simultaneously creating not only creating, but also preserving the rural bank. So when we talk about that, then there are like 4 tiers starting from zero, then it makes 5 tiers. Basically, when we talk about such a sustainable architecture, then like most of the blame goes to the architects, that they are just making houses like anything. But it's not only the role of architect that is important here, because there are various stakeholders here. The prominent stakeholder is the person whose money is invested. So we should not be like going to the architect or not going to the architect and just making our houses like that. It's not like that. We need to have a proper handshake between the technology architecture, and economic on economic grounds, so that a perfect thing or a sustainable thing can be generated. So because of that, we have if we divide our various activities of building into tier 0 to tier 4, that is site design, building design, passive systems, mechanical and renewable energy utilization. So all these three components are like architectural dominated components, which are talking about that when the house is yet to be built, then what things needed to kept into consideration. These two tiers, that is tier 3 and tier 4, will dominantly come into existence for all those activities which we are going to take care once the house has been made, and now we need to make it more sustainable or more energy efficient in terms of what energy it is utilizing. Even though we can also incorporate these components while the new house is being developed. So when we talk about this, so tier 0 is the site design, that is landscaping, wind patterns, and building orientation and building shape. So when we go to a site, we need to understand that where the site is, what should be the orientation of the building, how the facade should be developed, so that maximum air can be brought inside the house, maximum lighting can be brought inside the house, so that we are utilizing natural ventilation and natural lighting to the most, rather than depending more on the mechanical devices. If at all we have to depend on the mechanical devices, then we have to search for the options for the renewable energy based systems, so that we are utilizing less of electricity. In turn, in that case, we are going to generate less CO2 carbon footprint for the environment. This is what is the reality and the smallest formula that we have to adopt. So the basic components in the site design calls for the landscaping, the wind patterns, and building orientation and shape. So what I was saying, that building orientation and shape is important, that we should have maximum sunlight on the house. We should have the house oriented or made in such a way that maximum wind comes inside the house. We should study, and this is the responsibility of an architect, that they should study the wind patterns first while creating a house. And because there are other techniques also through which you can create diversions or create hurdles inside the wind pattern, so that a new pattern can be created and the wind can be passed through the house or through the vicinity of the house. So this is what is all in the tier 0, that is site design. In tier 1, that is building design, it calls for various insulations, finishes, then optimized window area, that is what should be the design of the window, how it should be placed, what should be the proportion of the opening on the wall, the proportion of the door on the wall, so that maximum air and sunlight can be brought inside the house. How the shadings have to be made. And then what type of insulation materials can be used, which are for the benefit for various climates, like summers, winters, and rainy seasons. How the glass panels should be mounted, whether they should be open glass or closed glass, single panel, double panel, like that. They are movable or immovable or closed, like that. And there can be like ventilation systems also installed, like ventilators also installed for what we say, air infiltration and air circulation inside the space. Then the use of passive systems like passive cooling, passive heating, and passive lighting systems. When we talk about passive, that means we're utilizing more of natural nature-based things rather than energy-based things that are mechanical or electrical in nature. Then comes the tier 3 and tier 4, that is mechanical and renewable systems, in which we are using mechanical systems for active heating, cooling, fans, and lighting. But in this case, we prefer that they are intelligent in a way that we are controlling their utilization or the amount of energy or electricity they are using by controlling the way they are working. And if this is not achievable, then in that case we need to fit with the renewable energy, which are also intelligent in nature, so that they can be utilized as and when the need is there. Now, sustainability measures for a building are, as I've told you already with that the last diagram, that they are like into predominantly three factors, that is energy efficiency, waste management, and building materials, which are going to holistically counter the sick building syndrome things. So we are going to talk about for this presentation, I'm focusing only on the ventilation system and the natural lighting, which are going to contribute to the energy efficiency of the building and creating a convenient, comfortable dwelling inside the space, building space. Now, when we talk about ventilation system, so ventilation is basically an exchange of air within and outside the building, so that fresh air can be taken in every time. We all know that hot air rises up and cool air is coming, or the breeze is coming inside. And in the older houses, we used to have windows along with the ventilators, and those ventilators were always open so that the air can be circulated from that. But nowadays, in the present construction, the ventilators have gone because we are knowing that we are having air conditioners in the room, and mostly they are on, so the circulation of air will be done mechanically. But this nowadays has been proven to be not a very good approach, because we are using energy to do that when we can do it without utilizing an active system installed in the room. So ventilation works like air is flowing from interior to exterior, thus it's necessary to start maintaining air. So we need to just create an opening so that the airflow can be managed inside out, so that the air is always circulated from. So this is called air exchange. So the more air exchange is there, the better it is, because the more fresh air is inside the room. Of course, we need to talk about, and we need to keep into consideration that if there is some polluted space outside, in that case only we need to have mechanical devices associated with that space to get a clean air inside and to manage that thing. Otherwise, if the pollution level is not to that extent, then as far as possible, a natural ventilation system should be installed. And this is basically due to the difference of pressure within and outside the air, outside the building, that the air circulation happens. This is called air exchange. So this is standard data that an adult has a frequency of breathing like 60 breaths per minute, or 8 liters of air per minute we are taking in and bringing out. Then the oxygen consumption varies between 250 to 350 ml per minute. Then the pollutants that we have. Now when we talk about pollutants, it's not only the pollution that is coming from outside inside our houses. It is also about all those volatile things that we have inside our houses, like the polishes on the furnitures that we have inside the room, the dyes which are used to dye our fabric, like the couch clothes, the curtain, the fabrics that we are using, and also the paints that we have. If they are not lead free, then they are emitting lead for a longer duration of time, which we are inhaling. So these all contribute to the pollution. If the outside is not that polluted, the inside is already polluted if you're having such things in your room. So we need to create, the only idea is, the best idea, the easiest measure is to create an active air exchange. And that can only be done by having good openings inside in the building, so that the air can be circulated. Then we are always exhaling carbon dioxide. So that is one of the pollutant that is already there. Then it is from the various equipments, that is furniture, flooring, volatile organic compounds. Then whatever technology we are using, we are nowadays habitual of having TVs inside our bedrooms, and there are like 4 or 5 TVs in a household where there are 4 or 5 rooms. So they are actively emitting many things, many gases at a very low rate, in fact, but they are there. Then if you have an animal or a domestic animal in your house, then the things are all more worse, because they are having more microbes attached to them. Then there are other pollutions that are coming from outside towards in your building, that are from like traffic, or for example, if you have some bakery installed in your vicinity. So whenever they are making their baking their stuff, so the emissions are coming inside your house. Like that, there are many things because we are a part of society. So there are many things that are going to contribute to the indoor pollution. Now, ventilations are of various types, like natural ventilation, mechanical ventilation, and hybrid ventilation. Natural, we know that it's a common, it's a natural pressure drop between the inside and the outside environment. So due to that, whatever air comes and is exchanged through the external source, that is due to the natural ventilation. If we are using some device to do such an activity, then it's a mechanical ventilation. Hybrid ventilation is an amalgamation of natural and mechanical ventilation. It just keeps a tap on how much exchange has been done through natural means. If it is not adequate, then mechanical means will be switched on and the things will be done. And after that, it would be switched off and it will be put again to the natural ventilation mode. So it's like natural ventilation is what I was talking to you about in the TL0, that is site description. So what I was talking to you, that how the building should be placed within the flow pattern of the wind. So this is what we were talking about. These are the contours of the building and these arrows show the wind patterns. So how the wind should be, the building should be a part of the wind flow, so that it is taking, there's a natural ventilation or natural drop being created in the path of the wind in the form of a house, and maximum air is circulating or is passed through the house, through the terrain. You can see here. And this is also influenced by how the societies are created. That is what was contributing in the landscaping part. Like we create absurdly, we create societies. Like there are sections where if you go, you can see that the houses are very closely placed, and due to that, you cannot feel any air, any high-speed wind on your face, even though there can be a windy situation in an open ground. So this is typically an example, or typically happening due to the malconstructions of the houses, which is not allowing the wind to come into the what should I call it? Into the premises of the household. So so societies, that is why landscaping of a society is also very important. Abnormal constructions or malconstruction should be avoided. This is how natural ventilation occurs. The fresh air, which is cooler in temperature, comes in and hot air goes out. And this activity, shaft ventilation, can also be utilized to carry out such an activity in which the wind is selectively percolated to every room of the house and then taken out. Okay, this is mechanical ventilation. It's like it's a pressure balance system. Like the amount of air that is required inside will be brought in, and the exact amount would be given out. So it's like a closed unit where input and output are matched through mechanical systems indeed, but yeah, but these mechanical systems can be either active or passive. That means either they can be like on active electricity or they can be renewable energy controlled systems. Then like this washroom is a like under pressure room in which negative pressure difference is there. That is more air should come inside the room and less air should go outside exhausted from the room. Okay, so this is a negative pressure or under pressure system. Then overpressure system is like an operation theater. It's shown here, in which the pressure, it's like that. It's a positive pressure room in which air permeates from the room. Like less air should come inside the room and more should go outside the room, because we don't want an active exchange, because it will in turn call for more viruses or bacteria coming inside the room and infecting the sanctity or the sanitization of that space. So this is an overpressure room. So we already have such things or ventilation systems which are working for us. Then hybrid system is like a naturally ventilated room, but whenever it is required, the air handling units are there to manage the flow properly so that the entire room is properly ventilated. So these are the hybrid systems which are having both the natural and the mechanical ventilations for them. When we talk about lighting systems, so we have predominantly two types of lights, that is natural lighting and artificial lighting. And we know that natural lighting is like a solar light, that is sun radiations that are actively there for us, and artificial lights we create for ourselves. and we are habitual of using artificial lighting to the most. Now, just to see that how artificial lightings and solar lighting are different from each other, if we see here in this that there are prominently 4 type of lights that we have, that is incandescent, CFL, metal halide, and out of this, incandescent and fluorescent are mostly used in a household. This metal halide and high pressure sodium are the lights which are used in stadiums and your street lights and like that. So lumens and wattage and their efficacies, respective efficacies, are shown here. For incandescent light, that was the bulb that we used to have. It's like this white section shows the lighting area, that is this, and this yellow section shows the how much heat it is producing. So that bulb was producing only 7% light, for the heat that it was generating was 93%. When we talk about fluorescent, then it is like 22% of the light and 78% of the heat still being generated. That is too much. For metal halide, it is 30% and 70% proportion. High pressure sodium, it is 35% and 65%. But talking about sunlight, that is through a clear glass, it is 60% and 40%. So this is of more benefit to us. So if we can utilize sunlight to the most for the entire day of ours, then it should always be preferred, and medium should be made so that we are utilizing more sunlight, because this sunlight or sun radiation has more light spectrum. So the illumination of the room would be more as compared to the other mechanical sources or artificial sources of light. Also, this case might generate some glare. When we talk about sunlight ingress into the room, there can be a more glare because the light is very clear. There is 60%, the component is 60% light. So there can be a glare, but that glare can be managed by using shadings and creating some obstructions in the path of the sunlight. In that case, in that way, adequate illumination can be brought inside, and a good proportion of energy can be utilized. So these are the benefits, various benefits that of using a good daylighting option that enhance quality of sleep, reduction of stress levels, strengthen immune systems, provide improve learning capability, enhance productivity, boost psychological development. This is one of the most important thing, that stress levels are reducing and psychological development is happening, and reduction of health issues. This also contributes to lessen the solar radiations when they are coming more to the household. They're contributing to lessen the sick building syndrome to a larger extent, along with a good ventilation system. Now, a lot has been talked about it. So coming to a small case study that we have done on our university campus itself. This is our university. This may maximize. I hope this is visible to you all. If you see this figure, this is our central courtyard of the distribution of the university, and this is our central workshop. In this space, this is the maximized view of it. So in this zone is modeled. This zone was modeled, okay, in this activity, in this experiment. Yeah. So this room, what I've showed, what you are visualizing here, has been modeled here, and this is the solar tracking of this room, that how the sun is going to pass over this room. So we have done this modeling using rhinoceros and grasshopper plugins. Yeah. So this is the model of that room, which is having retrofit, which is having fitting like shaded areas like these, as shown here, because it's also having a connected room at the backside. And the front, on the front, there is also some shading. There's a window here, a bigger window, and there's a longer slit here along with the door, which we have considered that it is closed. So the entire light that is penetrating inside the room is from this big window here and the slit of the structure. So when we have done the Lumens analysis of this structure, since it's an office space, so we have done it from 9 AM to 5 PM in the evening for a particular day. Yeah. So this is a particular day in June because we have the maximum sunlight on that day. So we can see that in the case, these are the what should I say? This is the illumination inside the room, which is over the plane at the center of the room. When the light is falling inside from this and this slit, so how the illumination pattern of the room is. So this image is from the top view, showing that where this bigger square window is on this side of the image, and this calls for a longer slit, smaller, longer slit. So this is the image at 9 a.m. where the range of illumination that we're experiencing is more than 2000 lux. So that means it's a huge amount of light that is coming inside the room, which is not desirable at all, because that will account for more glares. Because in an office space, there are tables which are like which are having ceramica fitted over them, and there are other structures which are polished. So the light will refract from all the surfaces, and that will not be making a convenient sitting space for the occupant. So this is the pattern of that lighting throughout the day, from this being at 9 a.m., at 11 a.m., at 1 p.m., at 3 p.m., and at 5 p.m. in the evening. So what we did was we planned for some retrofittings here. In the retrofitting, we have created a shade here, and we have also tried to replace a single plain glass with a double pane glass. In this, due to this change of retrofitting, the changes in the illumination pattern that we have received for the same space were like what is shown here. And now you can see that a comparative ingress of the daylight inside the room has reduced to a level that is acceptable, that is above 200, and like very at a very little less state, it is more than 2000 lux, which is the acceptable range as per the ECBC. Now the entire room is having apt illumination, with at certain regions here we are going to use some artificial lighting to provide that. So after that, like with these retrofittings, if these retrofittings are placed there, what retrofittings we are talking about is the window glass has been changed, the shading has been provided, and at some extent, if we are going to give some artificial lighting here, then this is the energy consumption of that building, which states that this graph is without that change, without those changes, and this is with the changes that we have done, that is provided a shading, added a double pane window, and artificial lighting for some time. So if we see that the energy consumption, net energy consumption of this occupant space has been reduced from this value, that is 254 3.42 to 304. This is a very small change if you see for a single room, but when we talk about the entire campus, then it contributes a lot to that, because this change is going to be recursive in nature. Like this is for this change that I'm showing you here is for 1 day. Then after that, what energy requirement, energy consumption I'm showing you for 1 year, and this is for only one small space. If this is to be, if this type of activity is carried out for the entire space or a bigger building, then these small changes are going to add up and create a bigger difference. Now, this is why it is important for us to understand that if a proper ventilation system and a proper lighting is done, then we will always tend to use lesser energy and utilizing our resources to the best. Yeah. And this also calls for one more thing, that in tier 0 to tier 4, I have talked that tier 0, 1, 2, and 3 are from the architect point of view, and tier 3 and 4 are from the engineer's point of view, preferably mechanical and electronics engineers, because we are talking about intelligent systems and they are mechanical cycles basically. So when we are talking about these two sections of the society, nowadays we are having softwares which are capable enough to give us this type of an idea that how things are going to work for us in the longer duration of time. So in my opinion, this should be there should be a medium of understanding between the architects and the engineers. It's time that these people should come together, sit together, create buildings which are more sustainable in nature, utilize softwares to their capability so that they can provide very good information, well captured information to the stakeholders, that is the owners of the buildings, which are who are of no it's not their fault because they don't understand these things. They don't know these things, so that is why they will, and they don't understand these things. So if we give them a pictorial representation well in advance in the first hand, that these things are going to affect your net building quality or your occupant quality or your comfortable dwelling conditions in this manner well in advance, then these incorporations can be done in a building and a sustainable society can be developed. And with this sustainable society, this would be a sustainable society which is banking less on the banking more on the natural resources, utilizing less energy, thus creating less carbon footprints and having a sustainable future. So with this, I would end my talk, and I hope that I'm late by 10 minutes as was told to me. These are the prominent conclusions out of the case study that I have taken. Otherwise, what I've told you that it's a need of the hour that engineers should come together, sit together, and give a solution to all the technology that we are using, because this is an era of interdisciplinarity. And if the various fields are not going to come together, the word sustainability cannot be reached. So with this, I'll be closing my slide. These are the various references that I have taken, from where I've taken the data. So thanks a lot for your patient hearing, and open to questions.
Thank you so much, sir, for such a beautiful and lovely talk. We gained a lot of knowledge and enjoyed the presentation. I hope all the participants get benefited from this. Any questions? Okay, thank you so much, sir. Now, finally, I would like to invite Engineer Anamika, Coordinating Committee member, for the final vote of thanks.
Thank you, Azli. Am I audible?
Yeah.
Yes.
Okay. A lovely and warm afternoon to our most valued and worthy guest, Management Committee, respected faculty members, and participants. It is a matter of pride for me that I am proposing a vote of thanks for first day of FDP. On behalf of Electrical Department and entire Ycet College, I want to thank the chief guest, Dr. Rajnikant, Director, College Development Council, University of Jammu, who gave his vital time for his busy schedule to give the FDP. I would like to thank guest of honor, Professor Dr. Uvesh Abrol, Head Computer Science Department, University of Jammu, for adorning their necessary work and sharing with us his graceful opinion. I would also like to thank the speaker of the day, Engineer YATHESHTH ANAND, Assistant Professor, School of Mechanical Engineering, SMVDU, who delivered his talk on energy efficiency in building, a move towards sustainability. Thank you, sir, for your valuable time and sagacious knowledge. Thank you very much. I would also like to thank Chairman JGI, Engineer Vidya Simwal, for his valuable time and thoughts and give us platform to organize this kind of program. Thank you very much, sir. Also, I would like to thank Dean Ycet, Engineer Dinesh Gupta, sir, Chief Coordinator, Engineer Bodhraj Verma, sir, HOD Electrical Department, Engineer Lavnish Talwar, sir, Coordinating Committee members, technical team, and the anchor of the day. Thank you, everyone. Last but not least, I extend my thanks to the participants. Thank you, everyone, for their presence. Also, I request to all, please put your cameras on so that we can click a picture for the press release.
I request all the participants to please turn on your video for a group photograph. wait for another minute. We'll take another shot. This must take a while. Thank you so much. So I again thank you, especially thanks to Dr. Ycet sir, who will spare a time for us and give a beautiful talk. Thank you so much, sir. Ycet sir, thank you so much. I know you are not
Thanks a lot,
fit.
Lumens.
I know you are not fit, but again, due to your medical emergency, you spare the time and with us. Thank you so much, sir.
It's always my pleasure to talk.
So all the participants, the feedback link as well as the attendance link will be shared at the chat box. All are requested to please fill the feedback form. And this was the first day of FDP. In tomorrow, we have our second speaker. So we will meet on all at second day of the FDP program at sharp 11:30. Thank you so much. Thank you so much, Ycet sir. Once again, thank you so much.
Take care.
Bye, sir.
Bye. Take care.
Bye, sir. Thank you.
Thank you. Thank you.